These three questions will be. I'll go through these three questions. However, I won't tell you the full answer or the full method, but I will give you hints for these three questions. Try these questions yourself. Now, to answer this question, you should use the formula F equals ma. Because you know that the tension in the cable is 500 newtons, you've got the mass, which is 200 kilograms, the tension is 500. You can use F equals ma to find out the acceleration. Now, what else is in the question? So you got the final speed is 8 meters per second. Starting from rest, you know what that means. And you've worked out A. So first work out A. You've got V, you've got U, so find T. There's an equation that links A, V, U, and T. Part B, how far will it have gone? So you need to work out S. Work out S. So find an equation where S is the unknown, and you need to use A. I mean, it's better to use the known quantities you already have. So for part B, just find out S. Okay, and then for this question, a 12-gram bullet is accelerated from rest to a speed of 700 meters per second as it travels 20 centimeters in a gun barrel. Assuming the acceleration to be a constant, how large was the accelerating force? And you have to be careful of units. So you've got M, you need to convert that into, what do you need to convert the M into? U, what is U? You need to, well, in the question you're given U, you need to find that out. V, you're given that in the question. S, you're given S in the question. And A, you need to work out A, how large was the accelerating force? Now, the question is asking the force. So first you've got M, you need to work out A. Because you've got M and now you've worked out A, you can use F equals MA. So find all those quantities, it's already in the question. All you have to do is just work out A and then work out F equals MA. Okay, and then for this question, 3.40, a 5.0 kilogram mass hangs at the end of a cord. Find the tension in the cord if the acceleration of the mass is 1.5 meters per second squared up, 1.5 meters per second squared down, 9.8 meters per second squared down. So let's label all the forces. You've got the tension and you've got the weight. So those are the two forces. One's acting up, one's acting down. Now, to work out the resultants, because one's acting in the opposite direction, one of them is negative. So for part A, because it says it's going up, we're going to take T as positive and the weight as negative. So the tension minus the weight is equal to the resultant force. So if you just look at the diagram, one is tension, one is weight. The resultant force is tension minus the weight. And because you know that it is accelerating, so T minus mg is equal to ma. That is the resultant force. And then for part B, it says 1.5 meters per second squared down. So instead of the tension going up this time, the weight is going down. So we're going to take mg as positive and T as negative. So mg minus T equals ma.